Using the product rule to simplify square roots. The product rule tells us that if we have two items that are being multiplied together under a single radical sign, we can actually split this up to be the product of two separate radicals. The operation is still multiplication, but I've split the a and the b apart into their own square root signs. For example A here, I'm going to start by maybe just taking the numbers and the variables as two separate square roots. I know that the square root of 400 is 20, but if I wasn't sure, I would think about breaking the number 400 down into any factors that are perfect squares. 400 is the product of 4 and 100. So if we split this up into two separate square roots, square root of 4 and square root of 100, I would see, oh, I've got 2 times 10, which is 20. So yes, the square root of 400 is 20. For x to the 4th power, this is the same as x squared and then squared again. I'm writing it this way so I can kind of see how the square here and the square root symbol are going to cancel each other out. I've got some object, in this case x squared, that when I multiply it by itself, I end up with what's underneath the radical sign there. So the square root here is going to be x squared. So I think our overall answer is going to be 20x squared. For example B, we have a little bit more to think about because we don't have exact perfect squares under the square root. Let's try the same strategy we did for A, where we maybe separate things into their individual square roots. Let's put 50 by itself. Let's put x squared by itself, y cubed, and then z. Well, I already know that this guy can't be simplified at all because I don't have any exponents on the z, so that's just going to end up staying as square root of z. I like the x squared underneath the square root because that is going to cancel really nicely. So that one is going to end up being just x. Let's tackle 50 next. 50 is the same as 25 times 2. So I can split this up into the square root of 25 times the square root of 2, or 5 times the square root of 2. So that'll be this part. And then the last one is y cubed. If I rewrite this as, let's say, y squared times y, I can split this into y squared times the square root of y, so that this guy ends up being y, and I still have the square root of y. So kind of putting this all together, this, 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 and this, I think my overall answer is going to be 5 times the square root of 2. I have an x, I have a y, I have a square root of y, and I have a square root of z. For my final step, what I'm going to do is put everything that's still under a square root together, and then everything that's outside the square root together. So under the square root, I've got 2, y, and z. And this is my final answer. For these next examples, we're going to go in the opposite direction, where we've got two square roots that are being multiplied, and we want to combine them into a single radical expression. For example A, we have to have the assumption that x is greater than 0, because we're not allowed at this point to take the square root of a negative number. So if I'm going to use the product rule, I can multiply the two items together, this 50x and this 2x. I can multiply them together and put them under a single square root sign. So that would be 100x squared. This is nice because now I have something that's a perfect square. The square root of 100 is 10, and the square root of x squared is x, so my final answer here is just 10 times x. For example B, I could multiply 42 and 30 together, but then I'm going to get some large number and I might not know how to break it down into smaller components. Let's see, what's 42 times 3? Sorry, times 30. 42 times 30 is 1,260. That's a number that I don't know whether it's a perfect square. So instead what I'm going to do is think about breaking 42 and 6 down into their building blocks. I know that they both have a 6 in common, so I'm thinking about 42 maybe as 7 times 6, and I'm thinking about 30 as 5 times 6. So now if I put all of this together, I've got 7 times 5 times 6 times 6. This is nice because here this 6 times 6 is 36, and that's a perfect square. So that can come out into the front. So when I take the square root of 36, that'll be a 6 on the outside. And then 7 times 5, that's 35. Those are both prime numbers. We can't break them down any further. So our final answer here is going to be 6 times the square root of 35.